Hey everybody, welcome back to another edition of Geometry. It's Mr. A here, taking you through section 3.3. Today we're going to talk about slopes of lines. Maybe a little bit of a review for you since you've probably done some of this in Algebra 1 as well. But let's take a look today, okay? So first of all, our objectives today, we're going to find slopes of lines. Okay. And then we're going to use slope to identify parallel and perpendicular lines. Okay. All right, so first of all, let's take a look at what we've got here for slope. Okay. So the first thing here is when we talk about slope, you may have heard, and they've got it down here. You may have heard this term rise over run. Okay, so you may have heard this term rise over run. That's how we talk about slope. And so, you know, they talk about the words over here, ratio of the change along the y to the change in the x. Basically, what they're saying is this is just how steep is the line. Is it really steep and it goes up fast to the right? Does it just go up slowly to the right? Does it go down slowly to the right? Does it go down really fast to the right? So really what this is talking about, how fast or the steepness of these lines. Okay, so first of all, the rise. If I rise, I'm going to rise. Okay, when I did that, which direction was I going? I was going up and down, wasn't I? Okay, so if you look on our graph here, you notice the y is the axis that goes up and down. So that's why down here you have y's on top. So y2 minus y1, you're just subtracting the y values in these 2 points. Okay, and so now the run, if I am like running, I'm going sideways, right? When I run, I'm going sideways, and so that's x is the axis that runs sideways, and so that's why down here we have x2 minus x1. So we're just finding how much it changed from this point to this point with the x's, okay? So this is our formula here. This is very, very important. The y2 minus y1 over x2 minus x1, that is your slope formula. By the way, whenever you see m, when we talk about m is slope, okay? So m is the variable that we use for slope. I don't know exactly why. Maybe from the Latin word for mountain or something. I don't know. It could very well be. I don't know. I'm moving on. Let's look at a few examples here. So using our formula, we're going to find some slope here. So in this first situation here, we're given a graph. Okay. Well, what we can do here is remember our formula. I'm going to write it down here. So slope equals y2 minus y1 over x2 minus x1. Okay, so what we need to know is what are our points here. Okay, so this point here, remember the first number in an ordered pair is the x value. So from 0, we go 1, 2, 3 to the left. So this point is -3 for x, and to go up, we go up 1, 2, 3, 4, 5, 6, 7 from 0. So that's the point of -3, 7. And here from 0, we go to the left 1 and down 1, and so this point here would just be -1, -1. All right, so now what we're going to do is we're just going to put these into our formula. Basically, it doesn't matter which one you pick as the first x and the first y or the second one. It's going to come out the same either way. So you can do it in either order. Just make sure that you stay in the same order through all the way through that problem. Don't switch halfway through, okay? So I'm going to call this one x1 and y1, and I'm going to call this one x2 and y2. Okay, so in our formula here, take the second y, that's -1, minus the first y, 7, over the second x, -1 again, minus the first x, which is a -3, so minus a negative makes this +3. So here we have a -8 over 2. And always, 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 when you're doing slope, simplify the fraction if you can. So in this case, we don't want to leave it at -8 over 2. We'll just simplify that to a -4 over 1, which we can just write as a -4. This is our slope, -4. The other way, if you have a graph like this that you can look at this, you can just count it off on the graph itself. So we had a slope of -4. Remember, even though we don't usually write it, it counts as being like -4/1. So when I graph this, if I'm starting from this point, I go down 1, 2, 3, 4. Then I go 1 to the right. Hey, that's back on the line. Then I can go down 1, 2, 3, 4, and over to the right. Hey, that's on the line as well. So you can also just count it off when you have a graph there. Okay, let's look at another example. All right, this one we don't have the graph, we just have the points, but we'll graph it after we figure the slope. So let's go through this. I'm going to call this x1, y1, x2, y2. All right, so remember, on the top you just take the second y minus the first, so that's going to be +5. Remember, minus a negative. Second x, 6 minus the first x, again minus a negative, so +2. So it looks like this will be 7/8. So it looks like our slope is 7/8 there. We do not have a way to simplify that, so that's the best we got. So when we graph this, then let's just graph it, and then we'll make sure everything looks good. So -2, -5. So here's -2, and then down to -5. So here's -2, -5 right there. And then 6, 2 be right here. Okay, so that's our, now here's the trick. Can I draw a straight line between these 2 points? Close. And so so let's double check what we got here. If this is really a slope of 7/8, I should be able to, from this point, count up 1, 2, 3, 4, 5, 6, 7, and then go 1, 2, 3, 4, 5, 6, 7, 8. That's where the other dot is. So yep, that's correct. We've got a slope of 7/8. Okay, next one. How about this one? All right, same thing. We're going to call that x1, y1, x2, y2. You don't have to write these in here, the x1, y1, but if that helps you to get it straight, then I would recommend that. So we're going to take the second y, -1 minus a -1, so that's +1, right? Second x, 6, minus a negative, or +2. So when we work this out, -1 + 1 is 0. Uh-oh. What does that mean? Okay, well, if you type this in your calculator, what's going to happen here is if you do 0 divided by 8 in your calculator, you know what your calculator is going to tell you? 0. So when you get a situation like this, do not leave it at 0/8 or 0/-3 or anything like that. Whenever you have a 0 on the top of the fraction, just simplify it to 0. Now you might say, okay, well, what does that mean when I'm going to graph it over here? Okay, well, let's just plot the 2 points and look at it. So we got -2, -1 is a point, so like right here. And then 6, -1 is a point, that's going to be over here, if this will let me do a point. And so the line goes straight across. So therefore, when we look at the graph of this, we see how it looked, and we see the slope is 0. We see, oh, you know what? If we have a line that goes straight across, that's going to be a slope of 0. And if you think about it, that kind of makes sense, because remember, the slope was how far up you go, the rise, and then how far to the right you go, or to the left, the run. And so in this case, when we go from this point to this point, or any other point on the line, we're going up what? We're not going up at all. We're not going up, so we're going up 0. And so we go up 0, and then we go to the right 1. And then we go to the right 2 and to the right 3. So it's just a straight line straight across. So keep this in mind. You know, whenever you have a line that's just straight across, you know that it's going to have a slope of 0. Okay? Ooh, now look at this one. This one's a little weird too, because the slope is going straight up and down. That's a little unusual. Let's take a look at that. Let's find our points here. Since we have the graph, we have to find it. So this is the y-axis, so that means x is 0, and then we go up 1, 2, 3, 4. So this is the point of 0, 4. And then down here again, it goes, x is 0, doesn't go right or left, and we just go down 1, 2, 3. So this is 0, negative 3. Okay, so let's plug our points in here. I'm going to take the negative, this is going to be my x2, y2, this will be my x1, y1. All right, so what I'm going to do is I'm going to go negative 3 minus 4 over 0 minus 0. Ooh, 0 minus 0. All right, so what this means is we've got negative 7 over 0. What does that mean? Okay. Well, a lot of times people think, oh, that's just going to be negative 7. Well, but isn't negative 7 over 1 negative 7? So that can't be the same as this. Sometimes people might think, oh, it's 0 because of the 0. Well, wasn't in the last example we had 0 on the top? That was 0. So what's going to happen here? Well, if you type it in your calculator is going to say, error, can't divide by 0. This is not possible mathematically. And so what happens is we have to do something different here. We're going to say that the slope is what we call undefined. Okay, so whenever we have a situation like this, where a line is straight up and down, we say the slope is undefined. Okay, and so undefined is straight up and down. 0 is straight across, straight sideways. One way, a little trick that I have that might help you remember this, because sometimes people get confused when 0's on the bottom or when it's on the top. If the 0 is under, it's on the bottom of the fraction. If it's under, then it's undefined. So if 0 is under, then it's undefined. If 0 is on top, it's just 0. Okay? Just a little thing I made up. Maybe that'll help you. All right, so here's a little classification here. We just went through several examples here, and we saw each one of these scenarios. Okay? So it's kind of good to know a little bit about what your slope is supposed to look like, so you can make sure it matches up. Well, I don't remember what order we did it in, but we did one where we had a positive slope. If you have a positive slope, it should always be going up to the right somehow. If you have a negative slope, it should always be going down to the right somehow. A 0 slope will always be sideways, as we said, and an undefined slope is always straight up and down. What I do to remember this is, if you're going, usually when we read left to right, okay? So if you think about this line as going from left to right, it's going up, right? Up is positive, right? Up is positive, it's good, everything's great, we're up and we're positive. But if we're going from left to right, the slope is going down, down is negative and depressing, and oh, it's so overbearing. Negative slope is going down to the right, okay? So if your graph is going down to the right, you better have a negative slope. If your graph is going up to the right, you better have a positive slope. And of course, 0 and undefined, we talked about. Okay. All right, the other thing that we have to talk about today is parallel and perpendicular lines. Okay. If you notice in the little diagram here on the graph, we've got two parallel lines. L and M are parallel lines. Okay, let's take a look at their slopes, okay? Now, they don't have points on here, but if we look, we can see, hey, it looks like there's a spot right here on this line where it crosses right where those the two parts of the graph come together. So right here, and then it looks like here's another spot, like right there. So let's count from that point to that point. If we count, we go up 1, 2, 3, 4, and then to the right 1. So that would be a slope for this line right here, line L, a slope of 4. Okay, so slope of 4 here. What about the other one? Well, let's find a spot. Here's a spot right here, and then another spot right here. So if we count, we go up 1, 2, 3, 4, and over 1. Guess what that slope is? Also 4. Okay, so the first thing that we know here is that parallel lines have the same slope. Okay, parallel lines have the same slope. What about And as a matter of fact here, I covered up something else, but basically right here, parallel lines L and M have the same slope. It's both negative, both 4. I couldn't figure out how to get it off until the end, so it'll come off in a minute. This other line here, line X, is perpendicular because it makes a 90-degree angle here with line M and actually line L as well. Let's figure out what that slope is. So here's a point, it goes right through 0, and here's another point down here. So it's going to go down 1, 2, 3, 4 to the right. So it went down 1 and 4 to the right means its slope is negative 1/4. Okay, watch this one go away now. Woo. All right, so our lines that are perpendicular, for example, line X and line M, they have, now this doesn't say it here, but here's what I call it here. So slopes of perpendicular lines are what we call negative reciprocals. Negative reciprocals, okay? So what that means is, remember the word reciprocal means you flip the top and the bottom number. So remember this slope of 4 really counts as a 4 over 1. So if we flip that, the 4 goes to the bottom and the 1 goes to the top. It's exactly opposite from this. And the negative just means you change the negative sign. So if it's positive, you change it to negative. If it's already negative, you change it to positive. You just change the sign. So negative reciprocals, sometimes you might hear this called opposite reciprocals. It means the same thing. I like negative reciprocals because, you know, like I tell everybody, like, oh, you know, if you had a band, if I had a band, which in my mind I do, I would call it the negative reciprocals. And as a matter of fact, there's a picture, like a concert photo, that I'll put up for you right now. Take a look at this. Pretty neat, huh? So yeah, so there we are in concert. That's me on the guitar there. You probably don't recognize me, and I got my hair a little bit different. But anyway, so that's the negative reciprocals. So remember, the negative reciprocals, my band, and that's perpendicular lines. Okay, so remember that as we do the next couple of problems. All right, so here's what we're doing. We're taking line FG and HG. We're trying to figure out if they're parallel, perpendicular, or neither. Okay, and they give us the points. Okay, all right, let's start. So what I want to do is I just want to look at the slopes of these two lines and compare them. If they're the same, they're going to be parallel. If they're negative reciprocals, they're perpendicular, and neither would be pretty much anything else. All right, so let's start with the slope of FG. Okay, so the slope of line FG, so that means we're going to use these 2 points, F and G. So I'm going to go with -1, second y, minus the first y. So in other words, +3. And then over the second x, -2, minus 1. So 3 minus 1 is 2, and then -2 minus 1 is a -3. So it looks like the slope of that line is a -2/3. Just keep this in mind. If we got 2 over -3, that's the same thing as if you said -2 over 3, or if you just wrote a negative out in front, -2 over 3. All three of these mean the same thing, okay? If you have a negative on top and bottom, they cancel out to be positive. All right, so then HJ, here's the slope of line HJ. So now we're looking at this point, 5, 0, and 6, 3. So I'm going to take the second y, 3 minus 0, over 6 minus 5. So again, just doing the slope for both of these, this is going to be 3 over a -1, it looks like. Okay, and so that gives me just a -3. Well, are they the same? Nope. Are they negative reciprocals of each other? No, they're not negative reciprocals either, are they? So in this case, we would have to say they're neither. Let's graph it just to kind of make sure here. Okay, so if we have f is at 1, -3, and g is at -2, -1, so that is line FG. So that was F and G. And then the other one is H was 5, 0 and 6, 3. And there's 6, 3. And so that line looks something like this. I kind of drew it a little off there. Yeah, but you get the idea. It's not quite. It probably should have gone more like that. That's a little bit better there. What I drew actually looked close to perpendicular, and so those would not be quite perpendicular there. Oh, you know what? Guess what? What did I just do there when I did HJ? I said a slope of -3, didn't I? Oh. What should it have been? 6. What's 6 minus 5? +1. So this is still, it doesn't change our answer here. It's still neither. But you notice when I graphed the line here, what was I thinking? I said, hey, you know what? Why is the slope of this line going up to the right when I got a negative? Shouldn't that have gone the same way? So you notice when I graphed here, then I kind of caught myself and I said, hey, I counted this out. Well, actually, I just plotted the points. I didn't actually count the slope. I made the mistake over here. So that's a great, a great example for you to make sure, keep that in your mind, like what the slopes are supposed to look like. So it didn't change our answer here. It's still neither, because these are not negative reciprocals of each other. In order for this to have been a negative reciprocal, it would need to have been 3/2. That would have made it perpendicular. Okay, one more like this. So again, we're just going to find the slope of these two lines. So slope of AB. We're just going to go, what, 5 minus a negative, so +1, over 4 minus a negative, or +2. So it looks like that's 6/6. Oh, that's interesting. So that just comes out to be 1, slope of 1, or 1/1. And the slope of CD, then, now we're looking at C and D, so I'm going to go -2 minus 1, and then 9 minus 6. So this would be a -3/3, which would be a -1. Now this is really interesting here, because if you notice what happened, you might look at this and go, well, the sign changed, but I'm not sure about if it's a negative reciprocal. A lot of times it's a little easier in this, but remember, if we write 1, it counts as 1/1. So it's a positive 1/1. If we flip that, we still have 1/1, but we change the sign. So these are negative reciprocals of each other, and so this would be perpendicular. I'm not going to write out the whole word there. So these should be perpendicular. Well, let's graph them to take a look. So -2, -1, and 4, 5. That's a line. And then 6, 1, and 9, 6, 1, and then 9, -2. This just doesn't let me draw my points. And so there's the other line. And if you look there, it looks like they are make a 90-degree angle and that they're perpendicular. Okay, last example. In this situation, we're just going to graph a line, and it tells us that it's parallel, okay? So whenever you have a situation like that, it tells you that you have this certain point on your line. The first thing you're going to do is graph that point. So 5, 1, and it says it's parallel to MN. So we need to know what the slope of MN is, right? So slope of MN, I'm just going to do 1 minus 4 over 2 minus a negative or plus 2. So this would be a negative 3 over 4, it looks like. All right, this is the slope of MN. If our line is parallel to MN, what's our slope? Our slope is also going to be negative 3/4. Okay, so that's the slope of our line. And so that means from here I can count down 1, 2, 3. Oh, I'm going to go off the chart over here. It's going to be somewhere over here, right? Well, remember that this can also count as 3 over negative 4. We can think of the negative as being on the bottom. So let's do that. If I count up 1, 2, 3, positive 3, then I can go 1, 2, 3, 4 to the left. And if you look, that looks like that lines up about where we expect our other point to be. And again, I can count up 1, 2, 3, 1, 2, 3, 4. And so that would make our line, whoa, okay, that's a hard line for me to draw. So it would look something like that, approximately. And if you put negative 2, 4 here, if I can draw a point, negative 2, 4, and then 2, 1, if you notice that if we drew a line between there, it would be parallel. So that line there is parallel to our line. So you can see it works. Okay, I think that's it. So appreciate you being here for talking about a little bit of slopes and parallel and perpendicular lines. Till next time, Mr. Anderson, signing off. Bye.